Thanks very much, Brian. Good morning, everybody. And thanks very much for inviting me to speak at this workshop today. As Brian says, I'm the Trinity Vice President for Biodiversity and Climate Action. But as well, or before, or after that, I'm an ecologist. So I'm a professor of ecology here in Trinity. And as an ecologist who works in the middle of one of Ireland's largest and brightest cities, this interaction between the light pollution and our ecosystems is something that I have very little expertise in, but very great interest. And one of my favourite entomological stories that was published this year was from a paper published in Nature in January. And if I can get the slides to move. Is it this keyboard, Brian?
Yes, sure.
Oh, there we go. Thank you. Yeah, one of my favourite entomological stories was from a study by Samuel Fabian from Imperial College London and his colleagues who'd been working in the lab and in the field in Costa Rica to ask the age-old question of why insects are attracted and seem perversely to fly into lights at night. And what they found through the study was that insects aren't actually attracted to the lights. They don't steer directly towards them. Instead, their instinct is to turn their dorsum, so their backs, towards the light. And this is because in nature, generally, you tend to have more light from the sky than the ground. And by keeping more light above you than below you, it can help to maintain proper flight altitude and control. But under artificial light, this highly conserved behaviour of keeping your back to the light means that insects can fly continuously round and round artificial lights. And sometimes they get disorientated and fly into the lights. And this topic really fascinated me. Isn't that always the way when you find something that you don't know very much about? And as I looked into it, the more questions I had. So why doesn't this happen to other animals? What can we learn from this study to inform our nighttime lighting? How much does this already how much extra pressure does this put on our already damaged and degraded ecosystems? Apparently, it doesn't happen to larger animals because they are better able to cope with or respond to and react to gravity. So insects are small and light. They don't have the same capacity as we do to figure out which way is up and down. So that's why they turn their backs to the light. But this understanding of insect behaviour and specific responses to artificial light isn't just an interesting anecdote, and you would be amazed the number of people who are interested. It can help inform our practical decisions. So lighting design, what direction should lighting be reflected? What wavelengths are insects most responsive to? At what times of day are they most sensitive? And it's important that we pay attention to the little things like insects and all the factors that are affecting them, because insects are often ignored or worse, dismissed as pests, but they're really key to our ecosystems. They're both food for bigger animals that people tend to care a bit more about, like birds and bats. The bird in the picture here is a nightjar. This is a rare visitor to Southern Ireland, and it's an insectivorous bird, so it feeds on insects at the dawn and dusk. And these insects also play an important role themselves, but like most life on Earth, insects are under threat. Many of us have heard the newspaper reports of Insectageddon, the research that's shown global declines in insects. Often these research stories have been criticised for being based on small samples or limited numbers of years or coming from a limited number of sites or a limited sampling approach. But together, these studies are telling the same story. Many insects are in decline, both in terms of the number of species and in terms of their abundance. And this mirrors what we're seeing for nature across the board. So in terms of biodiversity loss, global reports have estimated that 1 in 8 species globally are threatened with extinction. That's of all species. And of the species that have been assessed here in Ireland, it's 1 in 5 species at risk of extinction. And the insects that I work on, the bees, that proportion is even higher. It's 1 in 3 species at risk of extinction here in Ireland. And these declines in biodiversity, in species across the planet, across Ireland, are driven by complex interactions of direct drivers, of habitat loss, degradation and destruction of habitat, of climate change, invasive species, overexploitation, and of course pollution. And this includes light pollution. These drivers are ultimately driven by us, by our behavior, our consumption, our policies, our governance, our economic systems. And these declines in nature, these declines in biodiversity, are not just important because of the moral, the ethical, the cultural, the historical value of nature, but because nature is our life support system and it underpins our economy. So we need to address all and every driver of nature loss, including light pollution. And we need to understand the effects of these drivers of nature loss on ecosystems and the benefits that ecosystems deliver to people. My own research field is in insect pollinators that deliver the important ecological role of pollination services, which enables the reproduction and seed production in the majority of plant species on this planet. And the effects of artificial light on plant-pollinator interactions and on pollinator services have become apparent through the work of Kevin, who will speak later on, and colleagues, among others. For example, this work is by Ava Knopp and colleagues, who demonstrated by setting up artificial lights on natural meadows that hadn't previously had any exposure to light, that nocturnal insects and their visits to plants were reduced by over half. There's 62% reduction in the visits of insects to plants under these artificial lights, with a 13% reduction in the reproductive success of those plants as a result. And the structure of the interactions, and these figures here show interaction networks, structures of interactions between insects and plants. The structure of those ecological interactions changed as well. So what can we do? What can we do about these impacts of light pollution on our beleaguered wildlife? Well, we can use our scientific knowledge and understanding, and based on scientific evidence, Georgia McMillan from the Mayo Dark Sky Park, in association with the All Ireland Pollinator Plan and Moths Ireland, produced guidelines on practical steps to reduce impacts of light pollution on pollinators. So in the left here, you can see this guide. It's freely available on pollinators.ie as part of the All Ireland Pollinator Plan. But there is nothing in the Irish National Biodiversity Plan, which was launched earlier this year, on light pollution or addressing the impacts of light pollution on nature. And so perhaps more attention needs to be drawn and paid to this issue at a national level. And we need to think about how light pollution and what we do to address light pollution and impacts on nature aligns with other environmental issues. And the other big environmental issue that's on most people's minds is the climate crisis. And here in Trinity, like other public sector bodies, we're obliged to adhere to the government's public sector climate action mandate. And this includes addressing carbon emissions and reducing our energy use. And one of the relatively easy wins is to replace our lighting with more efficient LED bulbs. So this reduces energy demands, it reduces associated carbon emissions, it reduces our bills, so it's cheaper, win-win-win. But of course, this does have implications for living creatures. And people in this room are probably much better versed to speak about this, the impacts on circadian rhythms, on the production of melatonin in humans, affecting our sleep patterns, affecting our health and our well-being, as well as affecting a whole range of wildlife. And given that here in Trinity, the focus of our sustainability strategy is the nexus between climate action, biodiversity restoration, and health, this issue of light and light pollution and how we tackle this is very relevant. So while we have light pollution affecting nature and affecting nature's ability to deliver the benefits that we get from it, it also has a direct and an indirect impact on our health and well-being. But there's massive potential for changes, for change in policy, in governance, in our institutions, in our infrastructure. And I look forward to Jana's presentation later on policy. But we need policy alignment and coherence. So we need biodiversity and climate policies and health policies that complement one another, not contradict each other. And one important step is meetings like this one today. So bringing together diverse stakeholders to agree that, yes, there is an issue, to think about what the solutions may be, and to provide the relevant guidance on implementing those solutions. And when I look at the list of people who are attending this meeting here today, I'm struck by the range of backgrounds, the range of disciplines, the range of expertise represented, from ecology and nature to architecture and heritage. We've academics, we've people working in the local authorities, policymakers, NGOs. This is a complex subject that involves a wide range of stakeholders, a truly transdisciplinary approach. So academics working with policymakers and practitioners, with local authorities, NGOs and private enterprises. And this is precisely the kind of research that we want to promote and encourage here in Trinity, particularly as part of our sustainability strategy. So I will finish by welcoming you here today, thanking you for your contributions in advance, and I wish you fruitful discussions and good outcomes from this meeting. So thank you.